Alrighty, the last question, and they throw together two of the most complicated topics at GCSE in this question, in my opinion anyway. First one is this one. It's a quadratic on the left, but it's got an inequality sign in. It is a quadratic inequality. How can we deal with this? Well, what you actually have to do, well, the best way to do this, okay, is to factorize it and sort of solve it to start with. So this is going to factorize x and x, two numbers that multiply to give 10 and add to give -7. That's going to be -2 and -5. And we're interested in where that is less than or equal to 0. Now, the way to go about this is a sketch, because I know when it's equal to 0, I'm going to get 2 and 5. That's the solutions to my quadratic. I'm just going to write that by it when equals 0, but I'm not interested when it's equal to 0, I'm interested when it's less than or equal to 0. Now, if I remember what a quadratic looks like, it's either a happy quadratic like this, or it's a sad quadratic like this. And because it's a positive x squared, that makes it a happy quadratic, and it's going to come down and look a bit like this. And I could even write this on, if I, another question I could be asked to sketch the quadratic, and that would be my answer. It goes through, it's not essential for this question, but it goes through the y-axis at 10. Okay, so where is this function? I'm now considering it as a function, y equals. Where is this less than or equal to 0? Well, it's here and here and here and here, and basically this bit that I'm shading in red. And so what are the x values where it's less than or equal to 0? It's this region here. It's everything between 2 and 5. And that's my answer. Now, at A-level, you get lots of questions like this, and sometimes you get it outside, so you can't always assume it's on the inside. And the sketch just makes it convincing. So learn how to do that if you haven't already. Yeah, setting it equal to 0, solving it, sketching it, and then looking at where it's less than or equal to 0 or greater or equal to 0 if it was that way around. Or you might get a less than or a greater than question instead. Okay, part B, just throwing in a different part of quadratics, and this is related to turning points on curves, and then we're trying to find out the quadratic itself. Okay, just going to throw a different quadratic out to start with. So if I had y equals x minus 2 squared plus 4, then this is actually a quadratic in completed square form. And why is this useful? Because basically this thing that's being squared, I mean, it's useful for many reasons. It's useful for solving quadratics, deriving the quadratic formula, but that's not for right now. Another way it's useful is that this thing here that I'm squaring is always going to be greater or equal to 0. It can never be negative. And so the function itself is always going to be greater or equal to 4, because I've got 0 as the minimum thing here, but then I'm adding 4 to it. And when is it going to equal 4? It's going to be when x is equal to 2, and then y is equal to 4. Now, why have I spent maybe 1 or 2 minutes talking about that? Because this question that we have is basically the opposite. We're actually being given the minimum, or the turning point in this case. We can see it's going to be the minimum because it's another one of these smiley quadratics. It will be a minimum right here. And then I need to work back to the quadratic. But if I understand that process, going from the completed square form to the minimum, or the maximum theory, then I can understand how to go from the minimum to the actual completed square form. So let's give that a go. It must be that y is equal, right? And let's go for completed square form, x. And because it's a -3, it's going to be the opposite. It's going to be +3. You saw how it worked here. When it was -2, gave a minimum of 2, because it's when I set x equal to 2 that this thing is greater or equal to 0. And then in this case, the minimum is actually -4. And that is my completed square form. That will give me a minimum of -3 minus 4. Okay, and we're nearly there now, and hopefully, like I've tried to explain it as best I can. It doesn't actually want that as the answer, but I'd get some marks for that. It wants me to now expand it, so that's not too bad. Just got to remember that this is actually a double bracket. You might have learned by now how to just expand really quickly in your head if it's squared, but I'm going to go a bit slower. Okay, so I'm going to get x squared plus 3x plus 3x plus 9. Sometimes people forget about the 3x bit. They just think it's x squared plus 9. No, you've got this 3x and 3x as well. So it's going to be, oh, don't forget the minus 4. X squared plus 6x, 3x plus 3x, and then 9 minus 4 is going to be plus 5. And I am done. That is the quadratic that will give me that turning point. A is equal to 6 and B is equal to 5. I think that is the best way of doing this question. There might be other ways, but hopefully you're happy with that.